This tutorial, we are going to discuss the laws and the rules of indices. Okay, so we'll look at some of the laws and the rules that you need to follow when you're dealing with indices. Okay, then in the other tutorial, we'll come with the practical questions where we'll be dealing with these indices. Okay, so let's start off and list some of the rules and laws that we need to use when dealing with the indices. Okay, the first one should be what do we do when we are actually multiplying indices with the same bases. Okay, so an index will have two parts. Okay, it will have a base. Let's say this is a base A and a power. Okay, so you can have a power M. Okay, so that's how an index is going to look like. It will have a base and a power M. Okay, so this is a power, and then this is a base. This is a base here. Okay, so what do we do when we are actually uh, multiplying indices that are having the same bases? So let's say we get this is an index with a power M and a base A, and another index with a base A and a power N. So in this case, what do we do? Okay, so what we usually do is to get the base. So you get your base, let's say A there, then you add the power. So you get your power M plus N. So that's what you do. So when you are multiplying indices with the same base, you actually add the powers. So for example, okay, if you are given, let's say 2 to the power 5 multiplied by 2 to the power 3. So this was going to be, so you get here 2, you can see this base and this base are the same. Okay, so you have a 2 and a 2 there, which are the same. Okay, so you get your 2. What you're going to do is to add the power. So you get your 5 plus your 3 there. So you end up having 2 to the power 8 as your answer there. So that's what you do when you are multiplying bases. That's the first rule that you need to know. Okay. Another rule, it should be when you are dividing. What do you do when you are dividing indices? Okay. So let's say you have this is an index with a base A and the power M. Then we are dividing it with another index which is having the power a base A and the power N there. Okay. So what we do, we get our base A and subtract the power. Okay. So in this case, we are going to get M minus N. So when you're dividing, you subtract the powers. When you're multiplying, you add the power. So for example, if you're having 5 to the power 7 divided by 5 to the power 3. So there, you're going to get 5. So you get your 7 minus 3 there, which is going to be 5 to the power 4. Okay, so that's what we're having. So when you're dividing, you subtract the power. Okay, so let's move. Another rule that you need to know is that when you have a number, let's say an index which is looking like this. So you have an index with a power and it's in brackets, then it's powered as well. So let's say you have A to the power M, then it's powered to the power N there. Okay, so what you do in that case, actually multiply the power. So you get your base A, then you multiply the powers there. So this power is actually affecting whatever is in the brackets there. So you multiply the power. So you get your A, M, you multiply it with the N there. So for example, okay, so for example, let's say we have 10 to the power 3, okay, then we are multiplying it with, we are powering these to 7, okay. So what we are going to do, we're going to get 10, then we get 3 multiplied by 7 there. So the answer is going to be 10 to the power 21. So that's what we have. Okay, so we can apply another rule for indices that you need to know. So it's this one here. When you have an index which is having a power 1. So an index with anything to the power 1 is going to be the base itself. So in this case, you are going to get the base as an answer. So you get A as an answer. Okay, so anything to the power 1 is the base itself. For example, okay, let's say we have 17 to the power 1. So get 17 as the final answer there. Okay, that's another rule that you need to know. Okay, so you can also have a base which is powered to 0. So anything to the power 0, doesn't matter what you have, is actually 1. So whatever you have to the power 0 is actually 1. So for example, if I get, let's say, 1 million, okay, so 1 million to the power 0, I power it to the power 0, it's going to be 1, okay? So if I get letters, they say A multiplied by B, then I say this to the power 0 is going to be actually 1 there. Okay, so anything to the power 0 is going to be 1. Okay, these are the rules that you need to know as well. Okay, so I can add another one. Okay, now let's say we have a fraction. Okay, so let's say we have a fraction A over B, then this fraction is powered to the power m. So what that means that you get your m, this m, the power there is affecting whatever is in the fraction, both the numerator and the denominator. So you're going to get a to the power m, okay? Then you also divide with the b to the power m. So you notice that this power is affecting both the numerator and denominator there. So for example, if you get, let's say, your 5 over 6, then you power it to 2, okay? So that means that you get your 5 to the power 2 divided by 6 to the power 2, which is 25, okay? So 5 to the power 2 is 25, then 6 to the power 2 is 36. So that's what you get there. Okay, now let's move with the rules of the indices. Okay, so let's say if we are having a power which is negative, so what do you do if we have a power which is negative? We have a negative power. So what do we do in a scenario where we're having a negative power? Okay, so in the scenario where we are having a negative power, so let's say a to the power negative m. So this will actually write it in form of a fraction. So we're going to get a 1. 1 is always the numerator. Then you get the base and the power the way it is, but you're going to get rid of the minus. So you'll get your base a to the power m without a minus. Okay, so that's what we have. So for example, let's say we have 9 to the power negative 2. So this, you always start with the 1 as a numerator, then to the power divided by 9 to the power 2 as your power there. You can see there we've gotten rid of the negative from the power. Okay, so immediately when you introduce a fraction, the negative from the power goes. So we remain with the 1 over. So this 9 to the power 2 means 9 times 9, which is 81 there. Okay, so that's what we have. Okay, so let's look at last law for indices. Okay, so you can relate indices with roots. Okay, so for example, let's say we have an index which has a power as a fraction. So let's say we have a power as a fraction, let's say x divided by y. This can be written in this form. So your y becomes a root. Okay, so the y becomes a root. Then the base goes inside. Then the numerator becomes the power. So the numerator is a root, the numerator is a power, and the base goes inside. Okay. So for example, let's say we have 49 to the power 1 over 2. So that means that you have the root, which is 2. Okay. So when the root is 2, you don't show it there. So it's going to be the root, which is 2. Okay. Then you're going to have the 49. Then the power is going to be to the power 1 there. The numerator is 1. So this is going to be 7. Okay. Another example can be, let's say you have a 27 to the power 2 over 3. Okay. So you know that here the root is the 3 there. So it becomes the cube root. Okay. Then the 27, the base, you put it inside. Then the numerator 2 there becomes your power. So this will mean that the cube root of 27 is 3. Okay. Then you get your power, which is 2, okay? So meaning you're going to have 9 as your answer there. So these are some of the rules that you need to apply when dealing with the indices. Okay, so we'll end here for today. Thank you so much for watching this tutorial.